are on problem number 8. Problem number 8. The total daily profit P in dollars from producing and selling X units of a certain product is given by the function P of X. So the profit as a function of X is equal to 17X minus 10X plus B, where B is a constant. If 300 units were produced and sold yesterday for a profit of $1,900, what is the value of B? So we know that P of 300 units, the profit when you did 300 units is $1,900. Right? And we want to figure out B. So what is P of 300? So let's put 300 in here. We know it also equals 1,900, but let's put it here. So it's 17 times 300 minus 10 times 300 plus B. I just put 300 in for X because we're trying to find the profit for 300. And we know already that that equals 1,900. That equals 1,900. So what's 17 times 300? 17 times 3 is 51. 51, let's add those two zeros. Minus, and what's 10 times 300? That's 3,000. 3,000 plus B is equal to 1,900. And then we get 5,100 minus 3,000 minus B is equal to 1,900. What's 5,100 minus 300? 2,100 minus B is equal to 1,900. Minus B is equal to, subtract 2,100 from both sides, is equal to minus 200. B is equal to 200. And that is choice E. Next problem. Problem number 9. I will switch colors. The number that results when an integer is multiplied by itself cannot end in which of the following digits? Interesting. Well, what's a number when it's multiplied by itself? That's like squaring a number. So let's kind of study what all the perfect squares look like. So when I square 1, I get 1. When I square 2, I get 4. When I square 3, I get 9. Square 4, I get 16. 5 is 25. 6 is 36. 7 is 49. 8 is 64. So let's look at the numbers that it can be. We could go 9 is 81. Looks like it can be a 1, a 4, a 9. And we could keep going. 1, 4, 9, a 6, a 5. And actually, if we went to, 8 ends 64, so it's a 4. 9 is we already did that. And then 10 is a 0, right? It can also end in a 0. The choice is A. Well, A, sure, a number can end in 1. We just figured that out. Choice B, sure, a number can end in 4. Choice C, sure, a number can end in 5. That was 25 as an example. Choice D, a number can end in 6. Choice E, well, none of the numbers we looked at end in an 8, and it seems like there's a bit of a pattern here that it tends to be just a subset of these numbers. And also, we know that the other choices A through D, we can figure out perfect squares that end in those numbers. So we know that the answer is E. Next problem. Problem number 10. A bag contains only red marbles, blue marbles, and yellow marbles. The probability of randomly selecting a red marble from this bag is 1/4. Red, so I can say probability of red is equal to 1/4. The probability of randomly selecting a blue marble is 1/6. Probability of a blue marble is equal to 1/6. Which of the following could be the total number of marbles in the bag? Fascinating. So what we need to do is we need to essentially figure out the ratio of red to blue to yellow marbles. So first of all, what's the probability of getting a yellow marble? So the probability of getting a yellow marble is going to be 1 minus these, right? So probability of yellow is going to be 1 minus 1/6 minus 1/4. Let's see, we could put all of that over 12. That's 12 minus 2/6 minus 3/4. Right, minus 3/12, that's 1/4. And then, so that equals, what's 12 minus 10? That equals 7/12. So the probability I get a yellow marble is 7/12, right? So that means for every So let's write it all as a denominator of 12. That makes it actually a lot easier. 1/6 is the same thing as 2/12, and 1/4 is the same thing as 3/12, and they all add up to 12/12. So for every 3 red marbles, there's 2 blue marbles, and there's 7 yellow marbles, the ratio. So red to blue to yellow, yellow is equal to 3 to 2 to 7. And we know we can only get this type of a ratio when there's a total of 12 marbles, right? There has to be at least 12 marbles or any multiple of 12 marbles, right? If there's exactly one blue marble, if there's exactly 2 blue marbles, then there'll be 3 red and 7 yellow. And there has to be at least two of the blue marbles. So any multiple of 12 marbles will work for this type of ratio. So if we look at the choices, which of the following could be the total number of marbles in the bag? So out of all those choices, which of them are a multiple of 12? Well, choice A isn't. 10 isn't a multiple of 12. Choice C isn't. 18, 20, 30. Well, 12 is a multiple of 12, so choice B is our answer. And we just figured it out. If there were 3 red, 2 blue, and 7 yellow, then we get the correct probabilities. The key is just to try to figure out what the probability of getting a yellow is, and then realizing the ratios between the two. Next problem. Problem 11. When the sum of a list of prices is divided by the average of the prices, the result is k. What does k represent? So if I take the sum divided by the average, so let's say I'm taking the sum of, let's say 3 numbers. So let's say n1 plus n2 plus n3. I could do it n times, but just for simplicity, just to kind of, and I'm dividing that by the average. I'm dividing it by the average. Well, what's the average? It's n1 plus n2 plus n3 divided by 3, right? And if you divide by a fraction, that's the same thing as multiplying by the reciprocal. So it's n1 plus n2 plus n3 times 3 over n1 plus n2 plus n3. So this cancels out, and all we're left with is 3, which is the number of numbers we had, right? And you could have done this, with 16 or 20 or whatever. I mean, you could have said n1 plus n2 plus da 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 n, where I have, let's say, n sub, let's say I have m digits, and then divide that by n1 plus n2 plus blah 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 n over n sub m digits, and say, well, I'm dividing by m. This would have also simplified to m digits. When you do what they said in the problem, the result is just the number of prices that you are summing. So that is choice D, the number of prices, and it works out because this sum and this sum will cancel out. Next problem. Well, let's see if I can fit this one in. So I have a drawing. It looks like this. Let's see. Triangle, 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 then dotted lines, dotted lines, dotted lines, dotted lines. It says, if the area of the square in the figure above is 81. And so they're just saying this is a square. And if the area is 81, then we know that this side is 9 and this side is 9, right? This is 9 times 9. And the perimeter of each of the 4 triangles is 30. So the perimeter of each of the 4 triangles is 30. So the perimeter is 30 of each of those. What is the perimeter of the figure outlined by the solid line? Well, think about it. The perimeter of the solid line, that would be this. That's that. That's what we want to figure out. Well, wouldn't that just be the perimeter of the 4 triangles? And then we want to subtract out this side, this side, this side, and this side, right? The perimeter of the red part is the perimeter of each of the triangles added up, all 4 of them, minus the perimeter of the square inside. So the perimeter of the 4 triangles is 30 times 4 minus the perimeter of this, which is minus 27. Oh, whoops, minus 36. So it's 120 minus 36. and that is I'm